Hello, welcome to Questions and Answers. We've had a question here about how to take a 10 gauge wire and terminate it into a spade properly. Well, what we decided to do, the best thing to do is to do a video and actually show you the process that we use here at Virtual Dynamics in order to terminate 10 gauge wires into spade connectors. Now you have to realize that a 10 gauge wire is a little bit bigger than the standard in high-end audio. Most of the manufacturers are using smaller wires because they're flexible and they're easier to install and they please customers a little bit more. But one of the common factors is that as you increase the gauge size of the wire, you lower the total amount of resistance, which allows more signal to move from point A to point B. And so the simplest way to be able to make your audio system better is to start increasing the gauge size of the conductor. So to use a 10 gauge conductor like we have, this is a 10 gauge solid core conductor. Now, a 10 gauge solid core conductor is going to look considerably smaller and quite a bit different than a stranded conductor. Now, depending on the amount of strands that you have in your stranded conductor, it may have an appearance to be a much bigger conductor, but there's the same amount of electrical energy space available in both sides of the cables, no matter whether it's a stranded or whether it's a solid core conductor. I highly recommend the use of solid core conductors. The reason why solid core conductors are better are covered in some of the other videos that we have on our website. You can check that out. But if you're going to go ahead and terminate a 10 gauge wire and you want to terminate into a spade, how do you properly do that? Well, the first thing you've got to be able to do is to go ahead and do all the work that's required in order to be able to terminate your spade properly. So the first thing that we did is we took apart our little spade and we drilled a hole in the back side of it and we tapped that for a little screw to go into the back of the actual spade itself. And the screw is actually going to create a mechanical joint between the conductor and the actual spade itself. So we can take that little conductor, we can put it on the edge of the spade here, and basically the thing will stay. Now that's a mechanical connection. What we want to do ultimately is we want to turn this into a joint. A lot of people are believing that this particular type of connection is the best. In fact, I did for a while too, simply because I had read a number of different threads about how if you terminate with a mechanical joint, you don't have the problems of solder, but you also don't have the benefits of an actual joint either. You have a mechanical connection which suffers from a lot of different problems. One of them is that over a period of time, vibration can wiggle them loose, and that oxidization and things like that are more prone to being able to get into a mechanical connection. A mechanical connection is good for one purpose and one purpose only, really, and that is when you put your conductor in, when you put the screw into the back side, you're basically taking and you're pushing your copper right up to the front side of the hole. And that means that if you do that with every one, you're going to have approximately the same amount of solder between the actual conductor and the connector, or the conductor and the connector, as you do from, let's say you're doing 4 of them, number 1 and number 4 will be very similar. Once you remove the idea of having the screw in there, you can physically move the conductor back and forth with inside here. And so the difference of the spacing between how much solder that the electricity is going to have to flow through from connector to connector can be quite different. So the mechanical joint here itself helps to eliminate that particular problem. So you want to torque it up relatively good so it's nice and tight in there. And then you put it into a vise. Now, one thing I'm going to do here first too is I'm also going to show you the process of tinning. So the first thing you'd want to do, just to get your conductor itself to have a solder surface on it, this process is called tinning. You just take a little bit of solder flux paste and then you take a solder. Now we use MG Chemicals cryo-treated solder. They don't cryo-treat it, we do. And the whole idea behind cryo-treating the solder is not the fact that we think that the solder itself, once it's melted, still is cryogenically treated in the form that it sits. We know that what we're doing is we're cryogenically treating the particles in the inside of the solder. That's what's important. We're kind of relaxing those. So all of the solders that we use are cryo-treated. And I'm going to take and just cover the end of this. Now you've seen I used a flux first. The quality of flux that you use and the kind of solder that you use are absolutely paramount to the quality of the connection that you use. A lot of people look out there for high-end quality solders. It's not so much that the solder that you're using is so specifically high-end. What's most important is that the solder that you're using is specific for the job that you're trying to do. So, for example, if you need a very low melting temperature or low melting temperature environment because you've got very small conductors, for example, then you want to use something that will melt at a low temperature, that will melt quickly and that'll allow you to be able to get your solder joint done and get out of there as quickly as possible before you start to cause too much heat to come up on the conductor itself. Because if you overheat the conductor, you'll end up kind of burning or scarring the metal on the inside. So we've taken the conductor itself and we've pre-tinned it before it goes into the actual connector. When you're looking also, the other key element for doing a proper solder job is a good quality flux. Now, we found a combination for this particular job that works very, very well. This is the Amtech solder flux. This is NC559-V2 is the solder flux we're using, and we're using the no lead MG Chemicals silver solder. Now, the other thing that you need to do is you have to have all the proper tools. This guy here is the Hackle 456 soldering iron. You can look at the sheer size of that guy. It will create an incredible amount of heat in a very short period of time. Now, in order to be able to get good heat transfer from point A to point B, the first thing you want to do is you want to take the end of your soldering iron and you want to wet it a little bit, because the wet solder is going to allow the conductivity of heat between the actual soldering iron and the connector. Again, we want to get in here and get out as quickly as we possibly can, and this guy allows us to generate a lot of heat very, very quickly. And so we're filling up that entire hole with solder on the inside here. You don't want to hold that any longer than necessary, but you can see when it kind of starts to boil at the top, then you'll have a really, really good solder joint. And that's what it takes in order to be able to build a good solder joint between a 10 gauge conductor and a connector. So we have both a mechanical connection and a joint being created. The mechanical connection of the screw is very quickly overcome by the difference in the conductivity of the actual solder. And this is actually cold enough now I can already touch it. So we had a low amount of heat on the conductor. It wasn't scarred very much. There's a fairly big mass in the connector itself in comparison, so we're able to put quite a bit more heat on it than the conductor, and we end up with a very good joint between your actual spade connector and your 10 gauge conductor. I'm Rick Schultz. Hope you enjoyed that.